Hi, everyone. Happy Computer Science Education Week. I'm Jocelyn Leavitt. I'm the co-founder and CEO of Hopscotch.
Hi, and I'm Liza Conrad. I'm the head of community at Hopscotch, and happy Hour of Code. It's our favorite holiday today.
We wanted to start out by showing a really quick video of the kinds of stuff that kids have made in Hopscotch. And then we are going to talk a little bit about how me and my co-founder, Samantha, who unfortunately couldn't be here tonight, why we decided we wanted to build Hopscotch. We want to talk a little bit about why block-based programming languages are really good. We want to talk a little bit about why learning to code is important. And then we want to do a little demo and show you how Hopscotch works and show you some of the stuff that other kids have made in it. But before we start out any of that, we just want to do a really quick video that we made to show off some of the things that people have made using Hopscotch. So let's run the video. So that's a quick little teaser reel of some of the stuff that kids have made using Hopscotch. We originally had some really cute ukulele music with it, and then we found that kids responded more to the dubstep kind of hardcore Skrillex remix. So let's go through here. So this is my co-founder Samantha when she was a kid. She grew up in Detroit, Michigan. She played a lot of sports. That's me as a kid. I grew up in Honolulu, Hawaii. I spent most of my time in the ocean. And neither of us did much, if any, at all, engineering or programming or coding at all as kids. This is us now. When Sam and I met, it was through a mutual friend who was a really good programmer, and we'd sort of gone through different routes and come into the New York City technology community and startup community through different ways. I went to a liberal arts undergraduate college. I studied environmental studies and geography. I was really interested in international development. I was really idealistic, and I was also really interested in education and experiential education. And I spent some time as a teacher. I taught in Hawaii. I taught in New York City. And then I went to business school, and I worked in private equity. And I had this idea for this travel app that I wanted to build. And I met Samantha through a mutual friend. Samantha had gone to Columbia, and she was a math major. She was an applied math major. And she had studied computer. She had taken one computer programming class, I think in her sophomore year, and decided she hated it and was really bad at it. And she was planning to be a pre-med. She had taken the MCAT and was getting ready to apply to med school, but she she was in this club, and she needed to make a website for the club, and she tried to find people to build it for her, and they were like, it's going to be $20,000. So she thought, okay, I'm just going to try to figure it out myself. And she discovered that she loved programming. And so she sort of began teaching herself programming, and after graduating, instead of going to med school, she became a computer engineer. And she eventually worked at a place called Pivotal Labs, which is a Ruby on Rails consultancy here in the city, and that's when she and I met. And we were working on this other sort of travel idea together, but we realized increasingly, we'd look around and we realized that programming was kind of a boys' club here and everywhere that we saw. Like a lot of our good friends that were engineers, a lot of them were guys, and a lot of them looked pretty similar to each other. I mean, a lot of them sort of had really similar stories. And we asked them how they got into programming, and a lot of them started really young. We heard the same story over and over again, and that was that they, when they were 10 or 11 or 12 years old, they had loved playing video games and fallen in love with video games and decided that one thing that they wanted to do was learn how to make their own video games. And that was the story we heard over and over again. And it sort of was in our mind. We're like, that's kind of weird. And then actually, right around this time, a few years ago, I went to this Hanukkah party And all these, and I sort of had this epiphany where all these kids got their presents. There was probably like 10 kids at the party, or boys and girls, and all the kids got their presents at the same time and opened them at the same time. And I realized that, like, I saw the boys getting these erector sets and these Lego Mindstorms and all these cool engineering toys, and the girls opened up their gifts and they were like pink purses and makeup sets, and I was like, oh, this is so wrong. And I called up Sam and I said, this is something we've got to do something about. Let's make a toy that we wish had existed for ourselves, and a toy that I could have given to those little nieces so they got the cool engineering exposure that the boys did. So we thought, let's make it. Let's try to make it. I mean, we at first heard that idea. We were like, that seems really cool. Let's make an engineering toy for girls. Wow, that seems really hard. I don't know. I think it might be too hard to do. And we sort of put the idea on the shelf. And then we came back around to it when we both. We came back around to it and we were kind of like, this seems like a great idea, and partly because we fell in love. We both had recently gotten these iPads, and we were just crazy about them. And we also saw that kids were crazy about them, and we thought, why don't we try to make this toy be something on the iPad? And so we thought about it in like what form this toy would take, and we were kind of, what would we have wanted when we were growing up? We could have done, like something where you get some sample code and you practice typing code, or you solve a puzzle, or there's like a game where you need to solve different levels to get to figure out a solution, sort of like scaffold up coding that way. But really what we would have wanted, it was sort of, we were both kind of crafty kids, and we loved like DIY stuff, and we loved making our own stuff and being like, okay, like here's a kit to make your own terrarium, like here's a kit to make your own necklace or whatever. And we wanted what we were going to make to be really open-ended in that way, and we wanted it to be so that any kid could just have an idea for something and like have a kit. Instead of building a terrarium, you could build like a really cool game. And so we thought about what it would take to do that. So Liza's going to chat a little bit about the programming language that we developed.
Cool. Well, I kind of jumped the gun on the slide. So as you can see here, well, how many of you know what this is? Some hands in the air, a lot of kids' hands in the air. I think we have a lot of programmers here, don't we? I saw your faces. This is Python. This is a programming language. How many of you, if you're not a programmer, are super excited to dive into this? You get what's going on? No, not any hands in the air. Me neither. This is pretty hard to understand. It looks like you just closed your eyes and typed randomly, and this is pretty much what would happen. And we thought that, this is not very inviting, this is not easy to learn, and it's not fun. So let's build something different and better. Let's build something fun. So for all of the kids in the audience, this is probably going to look familiar to you. How many of you have seen this before? This is Hopscotch. Somewhere I can press to make the GIF play. Hopscotch is a visual programming language, and you use drag and drop blocks of code to write your programs. We're not the first to use programming blocks, drag and drop blocks. Scratch, Blocky, Alice, there are a bunch of other really smart companies who have used this technology before. But if you look here, you can see there's some really nice, pretty colors and a fun character in the upper left corner. That's Chalana. And so we think that Hopscotch is an intuitive, fun, easy way to get started programming and quickly learn how to build things that you're excited about. So one of the most important things is that you don't need to type to use Hopscotch. This may come as a surprise, but kids, and a lot of adults for that matter, are really bad typers. They're hunting peckers. It's going to take them a long time to write a sentence, let alone an entire program. So in Hopscotch, you use your hands and the iPad's touchscreen to drag your blocks into your code. And what that means is that there aren't any syntax errors. When you're writing in Python or in Ruby or any other type-based programming language and something doesn't work correctly, you don't know whether the error is with your logic, you didn't come up with the steps that are going to work properly, or because you forgot a semicolon. That's unnecessarily frustrating, hard, and unfun. So as you can see here in Hopscotch, when something goes wrong, you can pretty easily figure out whether or not, in this case, like this we did here, we didn't put the square steps in the right order. So you can just quickly change them, and it's played a few times, so you've probably memorized it by now, to fix your code. So here we go. We're just going to move the code back up, and now we fix the program. And this makes it a lot easier to learn the programming fundamentals that are really important.
And I just want to interject that was one of the other big things I think that we were thinking about when we were building Hopscotch, was that we knew that there were thousands of programming languages out there, and the specific programming language that you learn is less important than understanding how a program works, and understanding how to use a computer and use abstraction and branching logic and variables. All that, those are common elements of every programming language. And we wanted to make those accessible without overburdening them with a syntactically heavy environment.
So we've talked a lot about how easy Hopscotch is and how fun it is and how you can start and immediately make anything, but that isn't to say that it isn't powerful. This is not a program that you just use to draw a square as we did in our last slide. You can do that for hours, and plenty of people do, but you can also do really cool, complicated things with Hopscotch. It's what we call a Turing-complete language. And this is a pretty fancy way of saying that you can use Hopscotch or any other Turing-complete language to build anything in the world. You could even rebuild the internet with Hopscotch if you had unlimited time and unlimited storage. That's a few months out for us, but we're getting there. And what Turing-complete means, 4 things. 1, you can program your computer so that it can follow directions in order. It can make choices. It can repeat itself, and it can remember stuff. So those are 4 components that we've built into Hopscotch that enable it to be a really complex way to make all kinds of games and stories. And you can see here in this game, and some of you may have played it, this is Chicky's Spooky Adventure. It won Hopscotch's first annual Halloween contest. But this kid used Hopscotch to build this really complicated game where you're the Chicky and you're escaping from the ghost, and you're actually going up levels. Actually, in his mind, you're going downstairs into a dungeon, but he built multiple layers on top of each other to build this virtual reality with those same colorful blocks of code that you drag and drop. So even though it's easy and you can learn it in 5 seconds, you can spend hours and hours and make something really complicated. So that's what we think is really awesome, and what Jocelyn was speaking about earlier, of this being an open-ended tool and not just something where you plug in 1, 2, 3.
And I want to point out that for those of you who care about fancy vocabulary, Liza said the sort of easy to understand version of all of these things. But what when we talk about Turing completeness, Turing, by the way, Alan Turing is the guy that's the character that's the star of this movie that's out right now called The Imitation Game, which
we highly recommend.
But he was a code breaker in the World War II. The Turing test is a way to figure out whether or not a computer whether or not you can tell whether something is a computer or a person. But anyway, he was hugely important in his, the Turing completeness describes a programming language that is computationally universal. So when Liza talked about the programming language being able to follow directions and make choices and repeat itself and remembering stuff, what that means, for those of you who care about vocabulary, what that means is being able to follow directions is understand sequencing. Being able to make choices is understanding conditional logic. So that's like your if-then branching logic. Being able to repeat itself is the idea of looping. Being able to remember stuff is variables. And those are all things that Hopscotch and every other fully complete programming language has. So overall, this is sort of an introduction to what we were thinking about when we were designing Hopscotch, and we again wanted to make it really open-ended so that if you can imagine anything and if you can think of it, we wanted to make it so that you'd be able to build it. So before we get into the demo, I also wanted to take a few minutes to talk a little bit about why programming is important and why we think a lot of people should have access and experience with it. So let's see. So there's probably the most popular argument for this, and one that's sort of advanced by a lot of people out there and is sort of fueling this, you better learn to program or else. This is the software is eating the world argument. And this is a powerful argument for a reason. I mean, how many people here have used one of those three companies, Kayak, Seamless, or Uber? Yeah, a lot of people here have had experience with these. These were all, I think probably people in the audience can remember a time when you had to pick up a phone and call a travel agent in order to book an airplane ticket, or be able to, in order to get food, you didn't go online and pick off a menu. You actually called up the restaurant, and you had, people would drop off takeout menus, and you would look in the takeout menu and order off a paper menu by calling. And Uber, of course, plenty of people still hail cabs, but more and more I know people who just hail cabs at the touch of a button. And these are all companies that have become really huge, and even this company Warby Parker. I don't know if any of you know of it. It's around the corner from here. It's a store that sells eyeglasses, and yet it was funded by these technology investors because it had this sort of significant online component. So we're seeing that software is sort of touching every aspect of our lives in every industry around us, and so we realize more and more, like, there's not going to be anything that remains untouched by software. So the skills of being able to understand how to code and program things, those are going to be increasingly important as we move into the 21st century. And so there's sort of this sort of drumbeat of fear that, like, if you don't learn to code, like, the kids of tomorrow are going to be without a job, and America is going to fall behind. International, we're not going to be competitive as a country anymore. There's a 2 million, I think, a deficit of 2 million jobs where there will not be enough people who learn computer programming to fill the jobs that are open to them. So we think that those are certainly important, and there are things to think about, and there may be reasons to learn coding, but we think that it's important even if you don't want a job in computer programming. And even if you go into a job, you go into the woods and you never have it, if you never see another computer again, we think it's still important to be able to have access to a computer and the ideas behind computer programming. So why? Firstly, most importantly, this idea of algorithmic thinking. So the idea of being able to take a problem and break it down into bite-sized pieces, and understand that you need to be very literal when you talk to a computer. And also, there's this aspect of abstraction, meaning that you can look at a specific problem and figure out how to generalize away from that problem and apply that solution to a lot of different problems that are kind of similar. And we think that that's actually something that you don't get a lot of practice with in a lot of other places, and it's a different way of thinking about problems, sort of a very methodical way of breaking things down, and we think that that's really valuable in order to learn. Second thing, mental habits of persistence. So this was actually pretty interesting, and as a former teacher, everybody on the Hopscotch team, everybody's very idealistic, and me just as much as anyone else as a former teacher, and we didn't expect this to emerge, but what we found was that people were writing to us and telling us that one of the things that kids were learning from programming was this idea of grit, which is this sort of character benefit, a part of character education. That's something that's not necessarily explicitly, listed in the Regents exam, how well are you doing on this grit scale. But what happens with programming, and every programmer, anybody who's here who's played Hopscotch or programmed anything will discover, is that you don't always get things right on the first try, and in order to get it right, you have to keep trying over and over and over again. You can't get frustrated. You can't decide you don't want it to work, and it's really rewarding when it finally does work out, but you have to sort of be willing to be persistent and not give up when stuff doesn't work, and just sort of put your head down and continue to try stuff until it works, because there will be a solution. There will be a way to figure stuff out. Empowerment. This is really important also, because this is one of the ideas of one of our heroes in the company is this guy called Seymour Papert. and he was an educational psychologist, and he actually came out with this programming language a long time ago. Maybe the older people in the audience would know about it. It's called Logo. But one of his big ideas was that it's really important for kids to learn to program, if for no other reason than the feeling of mastery over computers, because we realize increasingly that computers are these really powerful objects. They're some of the most powerful objects in the world. You run huge, they control billions of dollars in the New York Stock Exchange. You can set off nuclear warheads through computers, and they're so powerful, and for so many people they're really opaque and inaccessible, and it feels like a black box. And the idea that you can actually get in there and move stuff and change things within a computer, that's sort of like this great empowering feeling, realizing, I think the quote is you looking, I think it's a Steve Jobs quote, that you poke the world and the world will poke back, and you realize all of a sudden, oh my goodness, I can have this effect on the world and I could do anything. I mean, that's really, really, really exciting. And so we want to give that opportunity to people too. Creativity. Okay, this is a really, really important one for us. As I said earlier, we really think of programming as more than just sort of a 21st century skill. We think of it as like a very powerful creative medium of expression, meaning that you can come up, if you come up with an idea, being able to make it, we sort of put it in the same camp as playing the guitar or painting a picture, or writing, a story. It's really, it's a way for you to express yourself. And we see that over and over again in our community. The stuff that kids come up with is amazing. And then lastly, collaboration. We think that this is really important for kids to practice, and we see this. I mean, there's sort of the stereotype of a lonely programmer, hunched over by himself in a corner, and just working by sort of like this, the dark genius in the corner working by themselves. But in reality, a lot of the software that we used is made by a lot of people working together. And a lot of the sort of the biggest cultural products that we've seen, like Wikipedia, for instance, there's a lot of sort of there's this idea of open source movement where the whole is greater than the sum of the parts, and you have all these different people that are working together to build something that's really amazing and contributing, and no one person could have done it themselves. And so understanding that everybody has something to contribute, everybody can sort of take and own a part of a big, great project, that's really exciting and important to us as well.
And I'll jump in and add that one other really interesting thing about learning programming in particular is these skills don't just apply when you're plugging away on your iPad or on your computer. These are transferable skills that we're seeing kids learn in Hopscotch and then take with them everywhere they go in their life. And so it's not just something you focus on today for these reasons, but it's a skill that's going to carry on and provide benefit over the course of a lifetime. So that's something we're really excited about. And now we're going to show you how it works.
So this is Hopscotch. This is a community. I'm going to start a new project. Here, I'll just do blank project. And I'm just going to do a quick demo showing you how it works. So when you start a new project, basically you're given this blank canvas, and you can figure out whatever it is that you want to make. And the way that it works is there are all these different characters that you can pick. They're called objects. Hopscotch is an object-oriented programming language. So each of these objects get their own sort of set of rules, and they're each sort of move independently, but they can interact as well. And I'll show you what I mean. So I'm going to pick the parrot here, and you pick it out, and you can add any number of rules that you want. I'm going to say when the play button is tapped, walk for the parrot. That means fly. When the play button is tapped, it walks. So what we can do is we can continue to add. I mean, that's pretty easy. We basically just coded a little routine for a particular character, and to get this to work like this, to execute like this on an iPad and a lot of other languages, it would have taken you a really long time. But we've made it so we try. It's always a balance between making it really between making it granular and making it quick and easy to use. So we're trying to strike the fine balance, but we think that this is good because we could also, if we wanted to, we could modify what walk means. We could have it, repeat 3 times and move forward only 20, and then maybe it wouldn't walk as far. There, as you can see. It's a little parrot. And then if we want to, we can also add more characters. We can put this tree in. Here, add a new rule. Maybe when the character is tapped, how about we have the tree breakdance? There we go. That's the tree breakdancing. It stood on its head and kind of wiggled. And then we can also add more rules to each of these different objects. So I can add a new rule that says, so this is something else that's really important. When we built this, as Liza said, block-based programming languages have been around for a long time, but there was nothing that had been built specifically for touchscreen devices. And we thought it was sort of a perfect marriage. But one of the things we really wanted to take advantage of was the iPad, the iPad's native input. So in addition to sort of just like when the project is started, when they bump each other, we also have ways for you to run events that are like when the iPad is tilted right or tilted left, when the iPad is shaken, when the screen is tapped. And we also have when the iPad detects a loud noise. This is my personal favorite. So we can have this parrot, when the iPad detects a loud noise, have the parrot. And what I'm going to do is I'm actually going to program a really, really simple game so that when the iPad detects, we're going to try to like get the parrot to go to the tree. I'm going to ask for some audience participation with that. And when it gets to the tree, what we'll do is we'll have the parrot do a little something, like a happy dance or something. So...
And this is cool because what you just heard Jocelyn say is that she's going to make one character's actions triggered by an interaction with another character. And that's a pretty big conceptual leap that we've allowed kids to make pretty quickly in Hopscotch by making simple games that have much greater significance.
I'm going to make the character, I'm going to make him dance. Okay. So here's my game that I just made. I need some audience participation. So in order to make the parrot move forward, we're going to have to make a loud noise. So if you wouldn't mind just clapping. There we go. Good job, everybody won my game that I made.
I think we had a bug in it, Jocelyn.
Oh, because it didn't stop? Here, can you...
So as we were saying earlier, it's a little bit easier to debug in Hopscotch than in other games, and I think I noticed that he has Parrot has 2 rules. Oh wait, when Banyan bumps Banyan. Well, we only have one Banyan, so he can't very well bump himself. I think we meant to say when Parrot bumps Banyan, something might happen. So let's try it again.
Oh, it's hidden. It's hidden behind the tree. Anyway, take our word for it. The parrot did a happy dance.
And it was easy to find our problem and mostly fix it. So what we would do, one thing, we could publish this and share it with the world. So let's call this Hello, Hi Apple. Hi Apple fans in Soho. And so now we're going to push this out into the universe where it appears here. And all of you Hopscotchers will know this is now out in the universe, and kids all over the world can see our project, play it, and then take what they've seen, put it in their own, get inspired. But we're going to go here into Featured and just take a quick look at some of the stuff that other people have been making and get an idea of some of the stuff that you can do. So one thing we see a lot of is really cool graphic art. Like Jocelyn was saying, Hopscotch is very creative, and programming allows you to build beautiful things. So this is a project that somebody has made that we think is really fantastic, and they were kind enough to make a shout out to the Hopscotcher who inspired them in the beginning.
This color palette kind of reminds me of Monument Valley.
Okay. And I saw a turkey up here. I want to know if other people were playing hopscotch over Thanksgiving. So I'm going to search and see if people were making turkey projects. And then that's great because I wanted to make a turkey project. And now I can look through all of these examples of cool turkeys that people have made. But I don't actually understand how to do that. So I'm going to ask for help, and maybe somebody's explained some aspect of that. And you can see that people all over the world are posting projects when they get stuck, they don't understand something. Because we have this network of kids in different countries, they can post their project out and ask a specific question, and they have legions of people who are waiting to help and share what they've learned. And in fact, they do. They branch the person's project and add new text that answers the question. And then they upload it again to the community, and the kid who asked the question gets help from a stranger around the world. And we think that's really cool and speaks to the collaboration that Jocelyn was talking about a little while ago. So back to some of the other stuff that people have made, everything from, where does our drawing guy? Games and drawings, and then we're going to show you guys a little something special for Hour of Code. So one of the things we've done is put together tutorials to help kids get started with these concepts and have some fun ideas. And one of them was a food fight, because programming allows you to do things on a computer that you can't do in real life. And a lot of us want to have food fights, but we're not allowed. So we decided it would be fun to make one in Hopscotch. So we're going to show you a little game. And this game was made by Computer Girl, and she's 10 years old and lives in Pennsylvania. She wants to be a programmer when she grows up. She learned about Hopscotch because she tried Hour of Code last year and thought programming was super fun. So she went home after school and was really excited and found Hopscotch in the App Store and has been programming every day since. So this is her food fight. And so it's a 2-player game. So she built it herself, and you can either play it yourself if you're dexterous and left and right-handed, or you can grab a friend and play it too. So Jocelyn and I are going to have a quick battle.
She, by the way, programmed everything in there, all the detail, the lockers, figured out all the code behind each of the characters as well. So I'm Cupcake.
I'm Bear, and Cupcake is about to go down. Okay, neither of us are very good. That's sort of the bottom line here.
Oh, Bear wins.
Oh, but I did win, true to my word. And I'll just show you very quickly what some of this looks like in the back end. And it's going to be a little complicated, but super briefly, you see this top rule when the up button is tapped. And Bear is going to move up by 50.
Change Y is like on the Y-axis. So go up and down on the Y-axis.
And we're going to see if that actually works. It does. And then, lo and behold, if you press down, you'll see that the code is here too. So you guys can all go home if you haven't and download Hopscotch, and there will be a tutorial for building this game in your app. So you guys can all build your own food fight tonight. Or as one kid did, you could build an animal fight, and the food throws animals back and forth. So you can take it in any direction you want to go.
Here, let's see. I want to see if I can find that. That was actually kind of funny. So this is the, here, food battle. Also, I hope you like our little factoids and stuff is loading. So these are different foods, and in order to throw, they throw people. Anyway, this is an example of the kinds of stuff that kids come up with that we never could have dreamed of. But having an open-ended tool like Hopscotch allows kids to have these ideas and just make whatever they want. I mean, there have been amazing things that have come out of the community that we could have never expected. And that's what's sort of really fun and exciting. And I think kids go into the community and they're inspired by the projects that they see other people making, and then they build on them. And that's sort of this collaborative things that we see these projects where it's like one kid will build one thing and then another kid will add to it and improve these projects. And it's really cool to see. And the kids, they like helping each other out. They learn from each other all the time, and so that's really, really fun and really exciting.
Can we go
Oh,
back?
here's I'm sorry. No, I just want to like play hopscotch projects. We were backstage, and Lezo was trying to make me practice, and I was trying to play Operation. So here's a project where you just tilt the iPad, and then you press on different colors, and then you can draw. I'll tap on the green button here, and it draws a green line. And it operates by like tilting the iPad, and so you can it's like an art generator. This is a project that a kid made. Just like they make these cool apps.
Can we go back to the computer screen? Cool. And as you can see here, this is Kitty Skater's website. This is a project, again, that the whole template is programmed in Hopscotch. We don't have templates that you can download and just write on top. She coded all of the backgrounds and the interactivity in it. But we're also excited just because kids love programming, and we're finding that this love emerging from something that other people are so afraid of, including me. I was terrified of programming before I really got into Hopscotch, and now it's something I really like doing. And we're seeing that happen around the world with kids of all ages, from kids who can't even read and their sisters and brothers are helping them move the blocks, to like a 60-year-old man in Greenland who was like, I can't wait till it's 5 o'clock so I can go back to hopscotching. And we're like, yes, we won't tell your boss. He might play at work. But so we're seeing there's a love of programming developing from this simple tool, and it's just something that we're so excited about, and we can't wait to hear your thoughts on it too.
Yeah. Just to reiterate, I feel like that's sort of the big secret, is that people, I think a lot of times when they think of learning computer programming, it like seems like it's so hard and such a chore, and like, oh, like that sounds so boring and awful. But actually, it's once you get into it, and if you can sort of overcome the initial hurdles of like just getting started, and you're able to understand a few of the bigger concepts behind it, it's actually really fun and really empowering. And we encourage everybody here to, if you don't already have Hopscotch, go home, download it, give it a try, make a game.
Make your food fight.
Yeah, thank you.
All right, we have time for a couple of questions from the audience. Go ahead and raise your hand, and we'll bring you the mic.
As we're going, thank you guys so much for coming out tonight on this snowy night, and thanks to Apple too. We're just talking to this computer girl this morning, and a lot of kids wouldn't find Hopscotch if it weren't in the App Store, and it's such a great resource. So we're so grateful to be here and sharing this story, and can't wait to hear your stories too. We really appreciate it.
Yeah.
Hi, thank
Hi.
you for coming. What language do you recommend people to start programming with? Who have no experience before.
With no experience whatsoever, Hopscotch. If you don't have an iPad, there are other block-based programming languages that you can use in a computer browser. There are a bunch of them out there. Scratch is really popular. There's Alice, there's Calico, there's Blockly. I think code.org may have just built a programming language also that's sort of like Blockly. So block-based programming languages, though, when we were talking about them earlier, to reiterate, those are really key. And that's something where, again, there are thousands of programming languages in the world. The most popular ones people probably have heard of, you've got your Python and Ruby and JavaScript and Java and C and Objective-C and C#, and there are thousands. And then there's these really obscure ones that nobody has heard of, and people are inventing new programming languages all the time. And it's sort of like once you understand the concepts behind programming, it's pretty easy to jump between the different programming languages. Once you understand how to program in one language, you can pick up another programming language pretty easily. What's really important is understanding how these concepts work. And that's why we recommend starting with block-based programming languages, because if you want to go on into a typed language. Now, what we are discovering is that as Hopscotch and other block-based programming languages become more and more powerful, like we say, it's Turing complete. You can actually build a lot of things in just in Hopscotch alone. And we are, continually we're continually making it better and better as it goes, and so making it more powerful. So, yes, that's my recommendation.
Hello. What language did you use to make the app?
The app was built originally in Objective-C. My co-founder Samantha, who you saw as a little kid, she actually started out in a programming language. It's so to be technical, it's a server-side programming language called Ruby. And then she taught herself Objective-C in order to build this. And then this summer, Apple came out with a new programming language called Swift. And so ever since Swift has become available, we've been building everything in Hopscotch we've been building everything in Swift. So all the old code is in Objective-C and the new code is in Swift.
So if I wanted to show some students how to use this, well, I guess two-part question. One, would you recommend looking at a project that exists already? And two, is it all open source? You can look at everyone's code, or?
You can look at everybody's code. That was like a big thing that was really important to us, is that any project, if you scroll through the community, there's a big button that says See Code, and you can download their projects and play with them and modify them. It doesn't actually modify the real project. You download a copy to your own iPad, and you can play around with it and modify it and learn that way. And we've learned that a lot of kids will start learning by modifying other kids' projects. Yeah, we also have a teacher curriculum guide available for teachers who are interested in implementing Hopscotch in the classroom that sort of takes you through steps of how you slowly expose kids to the programming environment and show them how to do more and more things within it.
As well as video tutorials, both in the app and on our YouTube channel, and we're building out that library every week. So there are lots of resources for them, both in the classroom and then also to take home and explore on their own.
Yeah, and what we've heard from teachers is that you just sort of need to get kids started, and especially if you sort of run a collaborative classroom, kids will just sort of start teaching each other. Like they'll figure out how to do stuff and they'll teach each other how to do stuff. And it's something that's one of the nice things about having this open-ended environment.
So I'm a student, and when you branch a game, what can you do with that game? Like basically.
That's a really good question. Are you a hopscotcher?
Yeah.
Yeah. The question for the non-hopscotchers is what happens when you branch a project? And that is the term we use for what Jocelyn was just describing, of downloading a hopscotch project into your own personal account. So what you can do all sorts of things, really. You can test something. So let's say as simple as the person has a project that has a green background. You can download it and go into the code where they make the background and change the color and all of a sudden see what it looks like with a green background. Or you can try, let's say there's a game and you're a scuba diver and you're swimming to get some treasure, and there are octopus who are coming to get you along the way. You can try adding another octopus and seeing what happens. So you can test incremental changes to try to understand how the game works. Or let's say somebody is using values and you've never used them before. You can try playing around with them again to understand. And then you can also, let's say you figured out something awesome and you added 8 more obstacles on the way to the treasure. You can publish it back into the community so that other people can learn from what you've done, and now you've created a new game building off of somebody else's. So you can both learn, you can contribute to what the other person has done, and you can put something new out there for the whole world to enjoy. Does that answer your question?
Cool. Well, thank you. No more questions? Yay.
Thank you, guys.
We'll be around afterwards if you want to come say hi or ask another question. One last big thank you to Apple. They have been incredible partners for us, and we're just so grateful for them for helping us get the word out about what we've been working on, why coding is important. So, thank you, Apple.